Paul Spencer, welcome back to the Russell Scott Show.
Good to be back with you again, Russell. Nice to hear from you.
Paul, in early February this year, we released our interview, Death Plane, The Secrets of the Boeing 737 MAX. This was just before the world changed due to a particular virus you may have heard about.
Yeah.
6 months later, we're here talking again about the future, not just of the 737 MAX, but that of aviation itself, which is very much up in the air. Regarding Boeing, do you think COVID-19 has hurt the aerospace company or, as an unintended consequence, given them more needed time to solve the various issues concerning the 737 MAX?
Yeah, interesting. It certainly helped the 737 production line, but of course that's only a small part of Boeing. So I think like all other aerospace manufacturers, they will be taking a big hit. The immediate problem is obviously nobody's flying, so there are no spare parts going out. And of course, the spare parts business is a big part of aviation manufacturing, whether you're engine or airframes manufacturer. I don't know the precise percentage, but you'll probably find that something like 30 or 40% of your income is actually from the maintenance and spare parts. So that's going to affect aerospace manufacturers. Lots of airlines have been cancelling orders. I don't have figures for the rest of aviation, but for the 737, since we were talking about it, they've had about 800 cancellations for the orders on the 737 MAX. Now, there's two items there. Of course, there's the slowdown in industry, plus there's the MAX problem itself. But that's quite a lot. Out of a total of 5,000 orders, they've had 800 cancellations. So, yeah, it's going to affect aviation quite a lot. And there's going to be knock-on effects for the next few years because there's going to be an awful lot of people are not going to want to fly for a while. There's going to be people who are afraid of flying, people who, because of the COVID-19 virus problem, they're going to be people who don't really want to go on their holidays because they're not sure about, the medical situation. They're going to be people who used to have business meetings, but now they don't really bother with business meetings, so they've learned how to do without them, and so they won't be flying either. It's going to be tricky for them. I mean, the hotels that I've been staying at recently, I don't know, I'm guessing, but half of their business was probably conferences, and they've not had a conference since the virus started, and they have no conferences booked at all in the next year.
You're still actively flying, correct?
Yes, I'm still actively flying. We're on a very, very small roster at present, but the airline likes to share out the flying just to keep us in check. Otherwise, it's a problem if you go out of check. And they've had to do all sorts of strange things with the licenses because we couldn't go and do training for the licenses. We couldn't go and get medicals and all of this sort of business. So there's been lots of deferrals to recurrent training and things of that nature. But we're getting a little bit of flying in now, so just to keep our hand in, basically.
All this madness in trying to get the 737 MAX fixed and get it back into the market, why is the 737 necessary? The 787 is a superior plane. There are others with better crash ratios, many with zero. What is the reason for so many different models?
Well, you need to satisfy various range and route criteria, and there is a big market for a medium size. This is a sort of medium aircraft for sort of medium routes. So in Europe, we would be doing from Northern Europe to Southern Europe, which is not very far. I mean, it's only like 4 hours flying. I don't know how that would be so much in America, but if you're going internal, you don't necessarily want a large aircraft like a 787, which is a long-range aircraft. It's very expensive to buy. It's much more expensive to operate. And on thin routes, you're not going to want that many passengers going to that destination. So you need a range of small aircraft, commuter aircraft, up to 100 seats, and then the medium aircraft up to 200 seats, which includes the 737. It's a big market. I mean, it used to be the biggest seller of Boeing. Maybe not the one they made the most money out of, because it's like selling small cars. You sell lots of small cars, but you don't make so much money making them. But Boeing had 5,000 orders, the 737. That's a big business by anyone's means. That's a big, big business. So it's well worth doing. But there are other people in the market. And this is what Boeing has to be careful about, because there are people biting at their heels, wanting to get that business. You know, we have Airbus, of course, very famous, very good, solid aircraft, you know, good safety record, pretty much the same price. I'm sure people would be interested in that. And then we've got the new Russian, the Irkut MC-21, which has just come out. It's not quite certified yet. They're doing certification this year. But that's the same size, the same market as the 737. But it's a brand new aircraft with a brand new fully carbon fiber wing made by Irkut. It's a cooperation between Yakolev and Sukhoi. So, you know, well-known manufacturers of high quality producing an aircraft that with Russian engines on it, because they do a Russian engine as well as having a Western engine, you probably find it's only 2/3 the price of buying a Boeing 737. So there will be openings for, you know, an aircraft of that nature. The only problem with the Russian aircraft is, I mean, they're very well made, very well produced, very good designs. The only problem they've always had with Russian aircraft is they don't tend to be quite so reliable. And that's been a problem for airlines. You know, instead of getting 98%, you know, dispatch reliability, you're down at 78% dispatch reliability. And that's a real problem for airlines. But, you know, at that sort of price, you know, I think, you know, throughout the third world and maybe the Far East and places like that, I think they'll take quite a lot of sales off Boeing if they're not careful.
Not quite the Ford Pinto, but the Lada of aviation.
Yes, the Lada. Yes, they've still unfortunately got that reputation, you know, which is a shame because the aircraft themselves are very well designed. If they could only get the reliability up and also the spares. The problem they had with the Sukhoi, they sold a number of Sukhoi Superjets, which is a sort of a 100-seater aircraft, into Europe. And a lot of them have been dropped and they're not being used at present because the operators said they couldn't get spares for the aircraft, which I couldn't understand at all, because that's where you make your money as a manufacturer. You make your money out of the spares. So why aren't you, you know, ensuring that there's sufficient spares for your operators? I don't know. But anyway, that's the problem with buying Russian at present.
Subsequent to our conversation that we had in February, U.S. Congress came out with a congressional report.
Yeah, that was interesting.
That's what U.S. Congresses do. They come out with congressional reports.
Well, I thought they were just there to try and impeach presidents. I didn't think they did anything else.
So in early June, a U.S. congressional report came out slamming Boeing.
Yeah, and it didn't really get as much publicity as I thought something like this would. I read the newspaper every day. I didn't really see this report, but it is, as you say, it's quite damning. And it's be worth going through some of these points. So they made 5 main points in this congressional report. The first one was, it concluded that extensive efforts at Boeing to cut costs to maintain the MAX program schedule and not slow down the production line undermined the safety of the jet. Well, that sort of sums it up from the very start, doesn't it? That this was all about, you know, I understand that costs are an important thing in manufacturing when you're making things. But, you know, when you're making something that's safety critical, the safety critical has to come first and the cost has to come second, of course. I mean, that's just axiomatic. That's understood by everybody. And it looks like Boeing was putting costs before safety. And I have to say, this is not really a new thing. It's always been a complaint in Britain, because obviously we had a very big aviation industry in the 50s, 60s, 70s, 80s. And it was always a complaint from the British that the American aircraft manufacturers certified their aircraft in half the time that it took Britain to certify an aircraft. So there was always the complaint and the suspicion that, they were pushing things through too quickly in America, even back in the 50s and 60s. And they got away with it, but sometimes you push too hard and you don't get away with it. The second finding is faulty assumptions led Boeing to not classify MCAS flight control software as a safety critical technology that demanded more scrutiny, not security. Faulty assumptions. Well, I think those faulty assumptions, I think, there were probably three main faulty assumptions there, and they were cost, and cost. I mean, this all comes down to money, doesn't it? I mean, it's pretty obvious that the MCAS flight control software is a safety critical part of the flight control system. The reason why it was sidelined and not even put into the manuals, so nobody knew about it, was all cost, and cost. If they had highlighted this system, if they had made this system as effective and as safe as it should be, it would have demanded certification. And that would have been a lot more cost. And then they had this little agreement with Southwest Airlines, where if there were any training costs because of the introduction of the new aircraft, then Boeing would have to pay for all the training costs. And so they didn't want any pilot or engineer training costs for this new airframe coming through. And so that is what led them to not classify MCAS as a safety critical technology. It was just a bolt-on little, it's just a little something extra. We don't need to talk about that. But yeah, that was all cost-driven. No designer in their right mind would look at MCAS and say it's not safety critical. But they did, strange as it may seem. And then we come down to number 3. It says, in order to avoid greater FAA scrutiny and increase pilot training requirements, we were just talking about that, Boeing practiced a culture of concealment that withheld crucial information from the FAA, its airline customers, and the pilots. Now, that's interesting. I mean, we've discussed this already, I suppose, but that Boeing concealed the fact that MCAS had been fitted to the 737 MAX. But it says here that this crucial information was withheld from the FAA. So not just the pilots and the airlines and the engineers, but it's saying here that crucial information was withheld from the FAA. That's a bit far out, really, isn't it, for an airframe manufacturer to not be fully involving the certification authority in the certification of their new aircraft. Deceiving them, basically, deceiving the FAA. And it actually gets worse than that, actually. Deception is bad enough, but it gets worse than that.
So far, this is merely a reiteration of what we already spoke about in February.
Yeah, it is. But it does go further. Number 4, it says inherent conflicts of interest among authorized representatives of the FAA who were Boeing employees authorized to perform certification work on behalf of the FAA, which jeopardized the safety of the flying public. So let's go through this one again. Conflict of interest among FAA employees, representatives, who were also Boeing employees. So they got 2 hats, which is ripe for a conflict of interest. Now, you might say, that shouldn't happen in aviation, but it does. That's a part of normal aviation. So we have the same in Europe. I don't know so much about manufacturing because I don't do manufacturing, but for line flying, we have embedded CAA inspectors who actually work for the airlines. And they perform tasks like SACA and SAFA, which are safety officers. You probably don't know this if you're not in aviation, but there are FAA and CAA safety officers who roam around airports and just do a spot check on an aircraft. and they have right to board, and they can board the aircraft, and they can do a complete safety check and a full check of the paperwork and the crew while the aircraft's in operations, passengers are boarding and so on, and yet you've got these people who are checking out the aircraft to make sure the operation is safe. Now, those inspectors often fly as pilots with airlines. So because they have to keep up their licenses themselves, they have to keep up their knowledge of the industry. So they actually fly for the airlines. They fly as first officers in the right-hand seat. But the crucial thing is they're not paid by the airline. They're paid as CAA or FAA inspectors. So they're not in the pockets, as it were, of the airline. They're completely independent. Their pay structure and the people they report to is completely separate from the airline. But they just fly with the airline to keep their experience levels up. But going back to Boeing, it seems it's not entirely clear. It says Boeing employees who were authorized by the FAA. So these don't sound the same at all. They sound like Boeing employees who were working for the FAA, not FAA employees who were embedded within Boeing. And that's a big difference. If your employer, if your pay packet comes from Boeing and not from the FAA, then you're working more for Boeing than for the Aviation Authority. And the problem is, which hat are you wearing on that day when something important comes up in your line of work? Do you have your Boeing hat on, or do you have your FAA hat on? Yeah, that's difficult. There's a conflict of interest there, and that shouldn't really happen. If you've got embedded people within Boeing, they should really be employed by the FAA. And then it goes on, and this is probably the worst of all of them. It says, point 5 here, Boeing's influence over the FAA's oversight resulted in FAA management rejecting safety concerns raised by the FAA's own technical experts at the behest of Boeing. Yeah, okay, let's look at that one again. So this is not FAA workers, not FAA inspectors, the people down on the coalface doing the work at Boeing. This is FAA management who rejected the concerns of their own employees, their own technical experts, because of pressure from Boeing, because of influence from Boeing, as it says here. That's Boeing telling FAA management what to do. So Boeing is not influencing the sort of inspectors and engineers who are working actually in Seattle on the production line. They're influencing FAA management at a high level. And of course, that's not going to be low-level people within Boeing doing that. That has to be high-level management contacts between Boeing and FAA management. It's got to go up to the level of Dennis, what was his name? Muhlenberg, who used to be the CEO of Boeing. It's got to go up to that sort of level, isn't it? If you're going to go down to the FAA and influence them. And what does it mean by influence? Are we talking bribery here? Under the table payments? What does it mean by influence? How was Boeing influencing FAA management?
Well, they work together in the industry. One can't exist without the other, so it's almost
yeah, they are a bit symbiotic.
Sort of a quid pro quo in a sense there. They both keep each other working.
I'm not sure about the FAA. The CAA in Britain has a bit of a dual role in that it oversees safety, but it also promotes aviation. So it has a dual role in that respect. But in terms of certifying an aircraft, I'm still wondering how Boeing can march into the FAA and influence them not to do a full certification check on a particular aircraft they are making. What sort of pressure can they put on them? And okay, obviously pressure was put on them, but why wasn't the FAA resisting? Why did they cave in to Boeing influence? It seems very strange, and I find that quite damning that should be happening. with something as important as the certification of an aircraft.
Well, it's wonderful to make a congressional report, but what are the consequences?
Well, one presumes they will strengthen the power and the control of the FAA. I mean, it's quite obvious that Boeing has had the upper hand in the certification process for quite some considerable time. And they got so cozy together that Boeing could almost make up the certification standards themselves with little or no input from the FAA. One hopes they are going to strengthen the FAA and make them more independent of commercial pressures. I mean, they shouldn't be influenced by commercial pressures anyway, but somehow they need to be strengthened. I sort of see what you mean in a way. I was listening to the very interesting tapes of one of our CAA test pilots. This is going back to the 60s and 70s. He was one of the chief test pilots for the CAA. And when he was testing these aircraft, the manufacturers were always saying, yeah, that's all right. That conforms to your regulations. And quite often he had to push back and say, no, that's outside the limits. You've got to do something about that. And there were to and fro's between the two of them to decide, whether changes need to be made on a particular new product, because obviously it's going to cost them a lot of money if they have to make a change. Yeah, I can see there's pressures like that. But at the end of the day, the FAA and the CAA have to set the standards, and those standards were not being set.
With the work that they're doing at Boeing, there are big changes to the MCAS system, which of course had to be made. Let's cover some of those changes. Flight control system will now compare inputs from both angle of attack sensors. If the sensors disagree by 5.5 degrees or more with the flaps retracted, MCAS will not activate. An indicator on the flight deck display will alert the pilots.
Shouldn't this have been done from day one? I mean, this is aircraft design 101. We're going back to infant school on this one. Nobody has made a flight control system that depended on one sensor for the last 70 years.
Well, now let's cover that first. First of all, there are two sensors. The MCAS system can only take input from one at a time. I don't know what the interval of those sensors are. If
on
they're
each
switching
flight, so each flight goes off on a different sensor.
Correct. Now, we talked about that before, so there seemed to be some misunderstanding in the comments. Some people thought there were 3 sensors. There are not. There are certainly only 2 sensors on the 737 MAX. We had talked about 3 and using an elective system where 2 of the 3 sensors would agree, and therefore that would be what is inputted into the MCAS system.
Yeah, that's correct.
That would be a superior design.
That's what
course.
They have on the Airbus. The Airbus has 3 sensors, and they have a voting system.
And let's make this clear too. You don't work for Airbus, correct? You have no vested interest. You've never flown one either.
No, I've flown on them, obviously. I know how they work. I've flown on the flight deck many times, but I'm not rated. You have to have a separate rating for all of these aircraft. I'm not rated on the Airbus.
And it should also be noted that Boeing doesn't make the sensors. In fact, the sensors for this plane are created at Rosemount Aerospace of Minnesota, Minneapolis. You could actually say that it was the sensor and this Rosemount Aerospace that have created the problem.
You could, but everything in an aircraft has to be duplex. You don't have simplex systems on an aircraft. The whole point of Performance A, which is the engine and airframe performance of an aircraft, how long it takes to get airborne down a runway, everything is predicated on having a system failure. In this case, mostly an engine, but any of the systems, whether you have an electrical failure or a hydraulic failure or a pneumatic failure or an engine failure, any single failure during your flight, not just the takeoff, mustn't endanger the aircraft. That is aircraft design 101. That's Performance A. That has been instituted on aircraft ever since the DC-3.
But I think it's also fair to say that it's not so much a failure of MCAS, but of the dependence on a single sensor.
Well, yes, but MCAS could have made a a logical decision here. You either have a three sensor system like they do on the Airbus, and you have a voting capability, or you have two angle of attack indicators, the sensors, and you can either differentiate the failure electronically. I was talking about this to an autopilot manufacturer who only do duplex, not triplex. And I said, why do you only do duplex? And he said, well, with the vast majority of failures, the computer system can detect that there is something wrong with that sensor because it's giving information that is, simply impossible. And so you can therefore reject that particular sensor. So that's one way of doing it. And the other way of doing it is you've got two sensors, and if you find a disagreement, then you just stop the system from working. Now, there are many systems where you wouldn't want to do that because you don't want a system to completely fail just because of one sensor. But on MCAS, you don't actually really need it for a flight. I mean, it's only there as a backup if something has gone wrong. So if your flight is going well, you shouldn't have to ever need it. So you could just have this voting system, and if it finds a discrepancy between the sensors, then it just turns the whole system off. Now, that could have been done during the design phase of the 737 MAX, and it would have cost them, I don't know, $150. I mean, that's what we're talking about. We're talking about $150 here to do that. 3 lines of code, If sensor A does not equal sensor B, turn off system. I mean, how long did that take? The reason why they didn't do that is because under the certification regulations, it appears that there was some sort of regulation that if a duplex or triplex system was added to an aircraft, you then had to do certification on it. And Boeing didn't want to do the extra certification. So they didn't make MCAS duplex. They made it very, very simple with just one sensor input. So that is not a fault of the angle of attack manufacturer, the sensor manufacturer, because, I mean, sensors fail. I mean, this is the real world. Whatever sensor you're making will have a failure rate. Okay, we don't expect a failure rate as as high as they had with the 737. I mean, they shouldn't be failing, quite so often, but sensors fail. And therefore, the system that uses that sensor has to be able to cope with failures.
On that note, we have an audience question. The MAX was flown for 2 years and more than 500,000 flights in the United States and by airlines in developed countries throughout the world without problem. Point being here is that there were many successful flights without incident. So when you say it shouldn't be happening this often, are we not talking about a very unusual circumstance here?
No, it's quite normal for a sensor to fail. That is normal, but you want a system that is robust enough that it doesn't require a test pilot to cope with the aircraft after a simple sensor failure. And I have to say, this would be a test pilot situation. I mean, you make aircraft to be flown by the dumbest of pilots. And, passengers might be shocked at that, but not every pilot is a test pilot. Same in any industry. Not every worker is the best of workers. I mean, that's just the way things are. So you make an aircraft so it can be flown by Mr. Average, or Mrs. Average nowadays, not by test pilots. So you've got to have a system that whatever is happening to that system, whenever it fails, whenever it goes back from full control to only partial control, like it does in Airbus, the system is still easy to fly. And that, I have to say, was not easy to fly. They had bells and whistles going off all over the flight deck. It didn't affect just one system. There was not just one thing happening in the flight deck. They had overspeed warnings. They had stall warnings all going off at the same time. They had stick shakers, they had lights, they had bells. There was a lot of chaos. on those flight decks. It was not an easy situation to control. And the other point is these aircraft are not necessarily in sort of first world conditions. They're out in the desert. I've still not seen exactly why the attack indicator failure actually happened. But if you're out in difficult conditions, dusty, sandy conditions, it is possible that you can get sand contamination in a sensor like an angle of attack indicator, because it moves. It has an arm that moves up and down. And of course, if you impede that movement somehow, then the indicator is not going to work. The sensor is not going to work. So was that a part of the failure? I don't know. I've not seen a report yet on exactly why those angle of attack indicators failed. But it's up to the airline to make a system that is easy to fly in all circumstances. That's the bottom line.
Back to how will MCAS change with the new software updates, and this is right from Boeing.com. If MCAS is activated in non-normal conditions, it will only provide one input for each elevated angle of attack event. There are no known or envisioned failure conditions where MCAS will provide multiple inputs.
Yeah, and that was crazy. Again, this is aircraft design 101 again. Why on earth did they have multiple inputs? I mean, who is in charge of designing this system? I mean, the whole system just sounded crazy from the very start. What it was doing before is if it detected a high angle of attack, it gave you trim forward. And then if it detected it again, it trimmed forward again. And it would do that all the way up to fully forward trim. But you never, ever would want full forward trim on an aircraft, whether it's high speed or low speed, even if you were stalling. So even if it was operating properly. So obviously in these crashes, it didn't operate properly. It operated at high speed instead of low speed. But even if it was doing its normal job, which is saving you from a low speed situation, you never want the trimmer to trim forward that much. Because once you've recovered your speed, obviously to recover your speed, you lower the nose down to break the stall and increase your speed. Well, now you've got full forward trim at the same time. Well, how do you pull out of the dive now? Because the trimmer is actually more powerful than the elevator, and so you can pull as hard as you like on the elevator and you're not going to pull out of the dive. The whole system just seemed ill thought out, is the best way I can put it. Crazy would be a better way of putting it, because you would never want that system to do what it was doing. And people were saying, oh, you might need it. That's why it was designed to do this. Well, now they've designed it not to do this. So why did they put it on in the first place? If now it's okay only to have one input from MCAS instead of 2 or 3, why was it ever given the authority to give you 2 or 3 inputs? Because it's the 2 or 3 inputs that cause the crash. If it had only been one input, those aircraft wouldn't have crashed. So why was there such insufficient design oversight that someone could add that system and no one picked it up and flagged it and said, well, this is the stupid thing. Why is it doing this? Why didn't the designers find that out before any of this happened? Why didn't the test pilots find that out before any of this has happened? I mean, that's what failure analysis is all about. You don't just fly the aircraft around from A to B and say, oh, that worked, that's fine, no problem. You go through every failure possibility that you can think of and see what the system will do. And obviously Boeing didn't do that. And why was that? Was that because they were rushing? Was that because of, what they were saying at the, what was it saying before? Extensive efforts at Boeing to cut costs and maintain the MAX program schedule and not slow down the production line undermined the safety of the jet. So was this all due to rushing? Nobody wanted to do a full check out of this system because it was going to cost too much money? Sounds very much like it to me.
Funny enough, from our first video, Death Plane, The Secrets of the 737 MAX, someone writes, the MAX is a magnificent aeroplane. All aircraft with engines under the wing pitch up with increase of power and pitch down when power is reduced. This is basic training on these types of aircraft. So perhaps we should be looking at pilot training instead of trying to find faults in the 737. That's the comment, yet they acknowledge that there are problems and they made changes.
Yeah, but that wasn't the problem. You see, the writer of that particular comment doesn't understand the problem. The problem was not the thrust of the MAX engine, the new CFM LEAP engine that they put on, which is bigger. Boeing arranged that the thrust line on the new engine was in the same place as the thrust line on the old engine. So the problem is not thrust, although thrust will pitch you up if you're not careful. The problem was aerodynamic. This new engine was so far forward on the airframe, instead of being tucked underneath the wings, it was so far forward of the center of lift that when you got into high angle of attack situations, the engines were acting like miniature wings. Actually, quite large wings, not miniature. It was like having a pair of canards on the front of the fuselage, you know. Canards are very, very powerful devices. Canards are those little wings that you see on fighter jets sometimes, that are way up on the front of the fuselage. And the engines were acting like canards. So as soon as you get into a high angle of attack situation, whether it was high speed or low speed, because you can stall the aircraft at high speed if you really try hard enough, those engines were acting like wings, but wings that were well forward of the center of lift and well forward of the center of gravity, and they were pitching the aircraft up. So the problem was aerodynamic, and there are limits. Yeah, I mean, the writer of that comment is correct. That's a part of aviation, but when you do certification, there are certain limits that you must be under, and that certain limit is a pitch rate, a natural pitch rate of the aircraft. And if you exceed that natural pitch rate in the stall, then you have to do something about it. And you have to redesign your aircraft, or you have to redesign your control system, or you have to redesign your computer system that controls the aircraft. But you cannot have an aircraft that will go out of control. And by out of control, I mean flip over on its back. Because the 737 will do that if there was no system to stop it doing it. So you could go up into a stall situation, high nose, lots of thrust, and as you slow down, it would get so much force through the engines and through the aerodynamics of these big engines that it would just flip over on its back. And of course, you cannot have that. And so you need some sort of system to prevent that happening. And Boeing chose this MCAS system that works on the trimmer. And I have to say that's probably not the best way of controlling that situation. Traditionally, as I said before in our last program, if you want to have an anti-stall device, you have a stick pusher. And so the stick pusher acts on the control column, it acts on the elevators to push the aircraft, the nose down, to push the aircraft forward, push the control column forward. That is a much better way of doing it, because when the aircraft recovers its speed, when it reduces its angle of attack, that system can stop instantly. Less than a second, it can stop pushing, and you're back into normal flight. The trouble with doing it on the trim system, as we've sort of indicated just a minute ago, is when it pushes forward on the trimmer, you cannot trim back very quickly. So after you've recovered from the stall, the nose is down, speed is increasing. Now you've got full trim forward. You can't pull back because the trimmer is too strong, and the trimmer will take 20 seconds to get back to its neutral situation. So you've got 20 seconds of heading towards the ground, mistrimmed, flying downwards, with the ground coming up at you at a rapid rate of knots. And of course, Ethiopia, in fact, both of these aircraft were at fairly low level. They were only about 2,000–3,000 foot up. 20 seconds is a long, long time when you're only 2,000 foot up and you're going down at 5,000 foot per minute. That's the problem. And so you have to ask yourself, is the MCAS system fit for purpose anyway? Even after they've played around with it and made these changes, is it fit for purpose? Should it be there? should Boeing have fitted a stick pusher instead? But the trouble is they're not now going to go back and put a stick pusher on it because it's going to cost too much money. It's going to take too much time. It's going to take extra certification. I thought when we had this long delay, because it's a year, when was it? It was grounded in March last year. So we're well over a year now into this situation. And the first crash, of course, remembered, happened even 6 months before that. So they've had nearly 2 years to work on this. I thought they would go back and make a stick push system and put that on and do it properly. But it doesn't sound as though they have. They've just gone ahead with a few tweaks on the MCAS system, and they hoping, fingers crossed, that that will be okay. But of course, EASA is saying, no, that's not okay. We've got now a separation between the FAA and EASA, which is the European Safety Authority, whereas previously EASA would always just rubber stamp whatever the FAA said. But because of the MAX situation, that, friendly agreement has gone out of the window. And EASA want to do their own checks and their own certification. And EASA have said, as I understood what they wrote, because they wrote it in sort of code, as they always do, is they will accept the FAA amendments to MCAS. But EASA want, within 1 year, I think it was, of the reintroduction of the 737 MAX, they want it fitted with a third angle of attack indicator, a third sensor, or a synthetic airspeed, which is another way of overcoming the problem. So what they're looking for is a triplex system instead of a duplex system. And EASA is saying that they will only give Boeing, a dispensation for 1 year before fitting a third sensor. So that's a problem for Boeing because they've got a lot more work to do on the MCAS system in order to make it triplex. A lot more work.
The third and final point of how MCAS changes with the new software update, I think, is a complete vindication of your opinions from our original show. MCAS can never command more stabilizer input than can be counteracted by the flight crew pulling back on the column. You spoke at length about this. The pilots will continue to always have the ability to override MCAS and manually control the airplane.
Yeah, brilliant, isn't it?
For them to say that they're making this change is an admission that this was an issue.
It was a complete admission that the system was not fit for purpose from day one. I mean, you just cannot. I just couldn't believe it when I found out, because it all came out in dribs and drabs. We didn't know about this when these crashes first happened. And I just couldn't believe it when they said that the system would trim fully forward. I mean, you just can't do that. Because, I don't want to go through this again because we've been through it at length. But yes, the trimmer system works on the stabilizer, and the stabilizer is more powerful than the elevator. So you can get into this awful situation where the trim is flying the aircraft, and you can pull back as hard as you like on the elevator, and absolutely nothing happens. You just go straight into the ground, which is exactly what happened to the Ethiopian aircraft. They were pulling and pulling and pulling, and the aircraft just nosed into the ground. Aircraft are built like this. The stabilizers have to be powerful because that's what you need when you're flying at high Mach numbers at high altitude. However, you cannot have a system like this MCAS system that has so much authority that it can fly you into the ground. I mean, that's just stupid beyond extremes. The question has to be, as we've just touched on before, is how on earth did this get through the design process, the testing process, and then the certification process? Well, we know that a lot of the certification process was flawed, you might say, because of point 5, Boeing's influence over the FAA's oversight resulted in FAA management rejecting the safety concerns raised by the FAA's own technical experts. So there was pressure at FAA level, perhaps, not to look too deeply into this system. But why would a test pilot not flag this up and say, this is bloody dangerous, guys, we're not going to do this? Was everyone so afraid of management at Boeing? Because there were reports, especially from the South Carolina assembly plant that they made there, that management was pushing for production more than they were pushing for safety. Was that true of, the testing regime and the test pilots and everybody else as well? How on earth did this system get through? You don't have to be an aircraft designer to know that this system just shouldn't be fitted to an aircraft. You've only got to have a private pilot's license to know that these things should not happen on an aircraft, let alone a very large aircraft.
How much of any plane, for that matter, is flown by autopilot, and how much by the pilot themselves?
On a normal flight, some pilots will put in the autopilot at 1,000 foot on the way up, and they will take it out at 200 foot on the way down. That's fairly normal for some people.
So takeoff and landing are done manually?
Normally, yeah. Pilots need to keep their experience levels. We don't have an auto takeoff system. I think there was one that did it recently. I think the Airbus A350 recently did an auto takeoff. But that's the first aircraft I've ever heard that has ever done that.
So is that why the worst part of the flight is the takeoff and the landing?
Yeah, because it's under manual control.
Because I don't want to slam autopilot. If you look at a vehicle, a car crash, the reason a crash occurs is almost 100% of the time due to driver error, not mechanical failure. We must have some reliance on computers, on technology, if not the great lion's share.
Yeah, it's getting like that in aviation. Crashes always used to be due to technical failures, but now they're more due to pilot failures and systemic failures within the industry. The problem we are getting is this interface between the pilot and the computer, or if you're in a Tesla, between the driver and the computer. It's always the interface between the two that is the problem. A hand-flown basic aircraft can be safe, and a fully computerized aircraft can be very, very safe. In fact, I would probably say safer than a manual controlled aircraft.
How difficult could it possibly be to turn off the autopilot or an MCAS system?
Well, not difficult at all, except they didn't know how to turn it off because it wasn't readily apparent what the problem was, because they had so many warnings and bells and whistles going off in it. It wasn't just a simple trim. If it had been a simple trimmer going forwards, they would have understood what the problem was, but they were getting overspeed warnings, stall warnings, stick shakers, and the trimmer all going at the same time. And of course, the stick shaker is so loud, it doesn't allow you to hear the fact that your trimmer is going at the same time. So they might
Okay, because that's what I could understand, because I was thinking, okay, they have a runaway trim, turn off the MCAS, do it manually. What's the problem?
In isolation, it's dead simple. But when you've got half a dozen lamps shining on the master caution system, you've got stick shakers going off, you've got the overspeed warning clackers going clack 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 clack, you've got the stick shaker going burr burr burr. I mean, it shakes the whole of the control column. It's not just a sound, it shakes the whole of the control column. It's designed to get your attention. That's why we have it. And of course, it does get your attention. But of course, when something gets your attention, then your attention is taken away from something else that might be happening at the same time. And that's exactly what happened. So this wasn't a simple failure. It would be easier in some respects just to have the computer to fly it. I mean, we could have fully computerized aircraft. That would be very easy to do. Well, not with the 737 because it's too old to make it fully computerized. But aircraft of the 787 variety, the new 777 that's coming out, all of the Airbuses, they could be made fully automated. You could take the pilot out of there as long as you had some way of allowing air traffic control to tell the aircraft where to go. You could fully computerize an aircraft.
Well, let me ask you this. I was just recently on a 787 Dreamliner, beautiful airplane. We flew into an electrical storm. There was a lot of turbulence. In that situation, do you rely on the autopilot, or is that done manually?
No, that would be on autopilot. It's much easier if you can get in flight and in the cruise, it's much easier to get the automatics to fly the aircraft so that you can manage the other aspects that need managing. So if you need cooperation from air traffic, if you need to avoid storm cells on the radar, if you need separation from all of that management takes up a lot of time. And so it's much easier if the aircraft is flying itself while you do the management of the flight. So that will always be done in auto flight mode. And as I say, most aircraft fly for most of the flight with the autopilot in. In fact, it's very awkward when the autopilot fails and you've got to fly the whole aircraft yourself for the whole flight, because their aircraft are fairly twitchy in the cruise when you're up very high. Not like at low level where they're fairly easy to control. They're much more twitchy and you have to have very, very small control inputs. And so it's very tiring if you're going to fly a whole flight manually. And if you go up very high, you're not allowed to do it anyway. If you go up into any flight above 29,000 foot into the new higher regimes, you have to have an autopilot actually flying the aircraft. Otherwise, you're not allowed to fly up there. And as far as landings go, we don't auto land very often. You have to auto land once a month just to keep the aircraft certified for auto landings and keep yourself in check for auto landings. But generally, we would only do auto landings in bad weather. So normally in bad visibility, you will do an auto landing, of course. But conversely, if it's very windy, you cannot do an auto landing because the autopilot system cannot do very windy landings. So anything above 25 knots in a 737, you have to land it manually because the auto flight system is not as good as a human for actually landing the aircraft. Well, on the 737 anyway. Most auto landing systems have a limitation on winds.
Does the 737 MAX use a 3 or 4-axis autopilot, and does it matter?
It's a fairly basic one actually. We're only Cat 3B certified, which means we have no rudder control. So the aircraft has no way of maintaining its lateral track on the runway after you've landed. It'll just go off the side of the runway. It has no way of maintaining itself on the runway. So we're only Cat 3B rated, whereas if you're in an Airbus A320, then you're Cat 3A rated, and you can land in much lower visibility. So yeah, we're only 2-axis basically. Autopilot hasn't really changed on the 737 for decades. I mean, it does its job, but we're limited to 150 meters visibility, whereas in an Airbus they can land in 50 meters of visibility, and that can make a difference sometimes if you've got really bad weather at your destination.
Audience question here: Boeing is better than Airbus. Airbus aircraft cannot be taken out of their operating envelope. While both manufacturers use fly-by-wire to move the controls, pilots who fly Boeing aircraft can still feel how the aircraft is handling on the flight yoke. Airbus does not allow for this feel. And having said that, we already said it earlier, you haven't flown an Airbus, so...
Yeah, well, I know how they work, but the questioner is conflating two different things. One is whether you can go outside the normal envelope, and the answer would have to be, why on earth would you want to go outside the normal flight envelope? The whole point of flying is to keep within the flight envelope. Otherwise, the aircraft will depart rapidly from normal flight. So even if you're flying a manual aircraft, you have to stay within the normal flight envelope. And what Airbus have done, and Boeing has done on the 787 and the new 777, of course, is they have put an automatic control over the flight envelope. And by what I mean by the envelope is the maximum and minimum speeds, the maximum and minimum altitudes, all that sort of thing. We end up with this box of parameters that you have to stay within. And it does it automatically, of course. So if you demand too much from an Airbus, it will say, nope, sorry, can't do that. And it will protect the aircraft. So it'll protect it and make sure it continues to fly. Whereas a Boeing 737, you can stall and spin it if you really, really wanted to. There is no system on a 737. Well, I mean, this is what MCAS is trying to prevent with this new MCAS system. But on a traditional old, even the NG 737, you can stall and spin a 737 NG quite happily. I mean, you don't want to, of course, but I mean, you do stall it in testing. They go up and they will test them, and they will stall the aircraft to see how it behaves, because that's part of the certification procedure. But they will do that with the Airbus as well. You know, for testing purposes on certification, they will take the aircraft up. They'll turn off the system, the protection systems, and they will test it to see how it stalls. And they say, okay, turn the computers back on again. And then you have protection.
By the way, when I was a young teenager, I was in the Royal Canadian Air Cadets, and we would fly Cessna 172s, and I, with the help of a pilot, of course, flew a Cessna 172, and we performed a stall maneuver. It was about the most frightening moment of my life.
Always good fun in a light aircraft. I've actually stalled big aircraft before, because I was on an aircraft that didn't have a simulator system. And so when you were checked out for this particular aircraft, you had to go and stall it, because there was no simulator you could do the stalling in. And so we went up and we stalled this aircraft, and it was exactly the same as a Cessna, really. The only difference was the pre-stall buffet, instead of being high frequency, the pre-stall buffet was sort of low frequency. And it did shake the aircraft around quite a lot. But it stalled very nicely. It dropped its nose and off we went. You know, that was the stall done.
Well, I mean, if people think turbulence is bad, try performing one of those.
Yes. Yes, it does make you light in your seat.
By the way, can turbulence be dangerous, or is it completely...
In general, no. It won't destroy the aircraft. I mean, aircraft have been through incredible turbulence and some incredible aerobatic maneuvers that they shouldn't have been doing, and they've not had any structural failure. So structurally, no, it's not a problem. The only problem with turbulence is the possibility of losing control. It shouldn't really happen on a large aircraft. It does happen on small aircraft because, of course, the effects are much greater on a small aircraft. Shouldn't ever happen on a large aircraft. I'm trying to recall any loss of control. I can't really remember. The only ones they had that they thought was loss of control was on the Boeing 737 again, when a couple of them rolled onto their backs and crashed. But that was found to be a rudder problem. It wasn't turbulence.
Have you ever personally experienced an emergency situation when flying? What was the worst flight you've been on that you had to fly?
Well, I fly older aircraft, so we have a number of failures. I've never had any major failures, so I've never had an engine failure. I mean, jets are incredibly reliable nowadays.
Have you ever been frightened while flying a plane?
No, because you're normally, if something happens, you're too busy dealing with the problem to be frightened about it. And if you're frightened about it, perhaps you're in the wrong job, basically. You have a job to do. So when you have a failure, you identify and sort out that particular problem and overcome it. And that's your job. And you're sitting there doing that job. And that job, is taking up, 90% of your brain capacity. There's no chance really of being afraid at the same time. Although I've never had the situation that the 737 MAX pilots were in. Perhaps that was a bit different. I don't know, because their aircraft were completely out of control. I've never been in that sort of situation. But in normal flight, it's not a problem.
For example, the Miracle on the Hudson, Flight 1549.
Yeah, again, I think they would be so...
Was that incredible? I mean, you could have done the same thing as Captain Sully. No?
You could, but you've got to make the decisions. The difficulty is making the decision. If you're indecisive, you might end up landing in the middle of the city. If you get into that situation, I'm sure people have been into it in whatever job they do, perhaps even in driving, and you've got to make a decision. But you've got to make a decision within the next 1 second. You can't sit and think about it. And some people do get rather tied up and overloaded, and they max out. And they're no longer capable of making a decision because they've got so many inputs coming in, some of which are contradictory. They've got to make a decision, and you've got to be very on top of the situation and very sure of yourself to make a decision, but not only make a decision, but make it very rapidly. And I liked that one with Sullenberger when I think they offered him another airport. And so he was without engines at the time. He was turning back to the airfield. And they said, we've got an airport out to your right side. I don't know, 5 miles, 10 miles, whatever it was. You can land there. He said, unable, instant. And that's what it has to be. You have to be so much in command of the situation that you know what the answer will be within 1 second. That's the difficult bit. Otherwise, you can get yourself into trouble. There are many, many ways that Sully could have got himself into trouble on that particular flight. It didn't have to end so nicely and neatly. It could have gone very wrong.
So he did the right thing in that particular example.
Oh, absolutely. Absolutely.
In that situation, let's say for argument's sake that you couldn't have turned the autopilot off. Would the autopilot be smart enough to have made that decision on its own?
You would have to rejig the aircraft completely so they have that decision-making ability. Present aircraft are not made like that. They have no decision-making ability. If you drive a Tesla, their computers will be light years ahead of any computer in an aircraft. This is the crazy situation where automotive engineering and technology has run ahead of aircraft. Because aircraft have dedicated pilots and the pilots need to be kept into the system, all of the decision making is being deferred back to the pilot. Now, Tesla has gone ahead and made an autopilot system which is specifically designed to make its own decisions, which an aircraft will not do. So no aircraft at present will make its own decisions like that. If you put an aircraft autopilot into a Tesla, all it could do is keep its speed and its heading, and that's about all it could do really. It might be able to follow a GPS track, but it's nowhere near as sophisticated as what they're trying to put into Tesla cars at present. So that's the difference. But that's not impossible to do, given the design brief to go and build an aircraft that could fly itself. It could be done in 10 years, easy, no problem.
Boy, we should just put Elon Musk in charge of everything, right?
Yeah, put him in charge of Boeing and they'd sort it out straight away, yes.
I know you want to talk about some of the wiring issues. I don't know how to segue into that except as I've just done, so go ahead.
Yeah. So there were some other issues that came up during this lengthy process that Boeing has been going through with the 737 MAX. And while they were trying to sort out all of these MCAS problems, they found some issues with the wiring, because the problem with the 737 is it was designed in 1950s. The actual certification is 1967. And back in 1967, the design requirements were different, which is why the 737 MAX would not pass modern certification. And one of those aspects that came up is the wiring down the back of the fuselage to the tail. In fact, it might be the wiring out through the wings as well, I don't know. But anyway, they were concentrating on the tail business, because in modern certification, you're not allowed to have power lines and sensor lines in the same bundle for obvious reasons. You don't want to short between a sensor and a power line, because that will screw up your computer completely. And because the Boeing wiring loom is so old, they have mixed bundles. And of course, someone came along and said, well, you really shouldn't be having mixed bundles in these wiring looms. And instead of deferring to the grandfather rights that the Boeing 737 can do this, they've actually said that they must change the wiring looms. Now, that's not much of a problem for aircraft that are in production. You can change the wiring looms fairly simply. And in fact, I don't know why Boeing didn't just change it anyway. I mean, it's such a simple change to do. If you know that new regulations specify a separation, why didn't you do it anyway on the MAX series? But anyway, they didn't. And the problem is the ones that have already been built. So there are sort of 800 of these 737 MAXes knocking around the world that now need all of the back of the aircraft tearing out and new wiring looms put in. With the best will in the world, that's going to take a lot of time and money to sort out those particular aircraft and put in new wiring looms. But apparently that has now been solved, and that is something that will be addressed when these aircraft are put back into service. And the other thing they found, which is unforgivable again, and again, you've got to be wondering what on earth Boeing are doing to have this problem. They did an inspection of fuel tanks, and they found FOD, which is debris, in 50%. Well, it depends who you read. Reuters said that 50% of aircraft had FOD in the tanks. Associated Press said that 70% of the aircraft inspected had FOD in the tanks. And Boeing didn't say what the problem was, but they said a range of debris had been found in the fuel tanks. And the last time this happened, it was reported as being tools left over and rags left in the fuel tanks. I mean, this shouldn't really happen. I mean, I know it did a long time ago. There was a famous case of a DC-10 many, many years ago that went in for its first major service. After 5-8 years on the line, working the line, it went in for a major service, and they found a vacuum in the fuel tanks. So it was a standard sort of Hoover upright vacuum cleaner, and was sitting there floating around in the fuel tank. But that sort of thing shouldn't happen. I mean, how much does it cost to have a team who inspect enclosures within the aircraft before they're sealed? Things like areas in the fuselage where you cannot easily see into them and so on. All those places that are eventually closed up, like fuel tanks and oil tanks. How easy it is to check that all of those places are, clean and fit for purpose before it goes out of the production facility. It sort of suggests that they're trying to rush to get these aircraft out of the door instead of actually, spending a bit of time on them. There was another one recently. There was a 787. They were doing an inspection of a 787, and they found a ladder and an engineer's wonder lamp in the tail of a 787. That sort of thing shouldn't really be happening, Boeing really have to get a grip of their manufacturing sites and make sure this doesn't happen. They were getting lots and lots of complaints about the new facility they made down in South Carolina. They made one in Charleston. They had lots of complaints of the airframes coming out of there. And they really have to get on top of this and get back to the understanding that safety comes first before pushing these aircraft out of the hangar doors.
Comment here from Charlie Brown. So I don't know if he's a cartoon or not, but
it's probably a cartoon.
he does claim to be a pilot. Regarding the two crashes, the real problem was that there were no pilots in the cockpit in either accident, which is news to me. Had there been, they would have flown the airplane and not crashed. They should have turned off the elevator trim and hand trimmed the nose back up. Yeah.
We're coming back to the idea again that this was easy to control, when I don't think it was easy to control. Remember, the first incident we had of this...
Well, it seems that we have a lot of apologists for Boeing who want to simply say it was pilot error.
Well, that's possible. That might be their motivation. But I wonder sometimes if they don't grasp the magnitude that was going on. They had another case that didn't crash. So this was the flight before Lion Air 6610. It had the same problem, but they didn't crash. They continued to destination. But if you look at the flight, I wouldn't have wanted to be a passenger on that flight. They had a number of major excursions from normal flights, you might say, while they dealt with this situation. So there was another flight where they were having difficulty controlling the situation. And in fact, they were saved a little bit, I think, because they had a third pilot sitting on the jump seat. It was not an easy problem to solve. And it's all very well thinking about this in hindsight. When we know what the problem is, we know how MCAS works. But remember, on the first of these crashes, they didn't even know the system had been fitted. They'd never been trained to actually deal with this situation. It was far from an easy situation to actually control. While you might say, X pilot or Y pilot would have been able to deal with this situation, sure, I'm sure there are many really switched on test pilots who would have dealt with this situation, but that's not what aircraft are made for. They're made for Joe Average. And by definition, the majority of pilots are Joe Average, Otherwise, you wouldn't have an average.
What are the most common reasons a plane should crash, or could, rather?
Well, statistically, the most dangerous bit is the landing. That has always been where most crashes occur.
Because it always seems to me when I'm a passenger, like I know there's always a bit of a sigh of relief when you land. I am aware of that stat.
Yes.
But it seems that, it's much safer being on the ground and something going wrong than being 40,000 feet in the air.
Yeah, we've had a few incidents in the air, which is, in the cruise phase, which is unusual. That's become more of a trend than we've ever had before. They need to do some more training for that, and an aircraft that is more forgiving in that situation. The trouble being when you're up at 40,000 foot, all the normal control inputs that you would normally put on an aircraft are very different. So the stalls are very different. Turning is very different. Getting too slow is a problem. Getting too fast is a problem. Everything is an order of magnitude more difficult when you're at high altitudes.
Well, how high can a plane fly safely?
Well, it depends what sort of aircraft you got. The majority of modern aircraft fly around the 40,000 foot mark max. The 737 is max flight level 410. There are some that go a bit higher. BizJets might go a bit higher than that. But nothing in the modern era will go above 50,000. The only aircraft that used to go above that regularly was Concorde, which used to go up.
I was just going to say the Concorde, yeah, right.
It used to go up to 60,000. It used to fly way above all the weather.
Wow.
Didn't even bother with airways. There was no such thing. It was the only aircraft flying, And also we're weight limited. So if you're heavy going across Europe, you probably find that most aircraft are stuck down in the mid-30s. 340, 360, simply because they're too heavy to go higher. Aircraft become very weight sensitive and very thrust sensitive when they're up at high altitude.
So you're burning a lot more fuel at these elevations?
Yeah, but that's all you can do. You're totally limited. You can't fly any higher, and you can only fly higher when you burn off a bit of fuel, and then you can actually climb up and get a bit higher. The real problem still is the landings, and not just the landings, but also the decision making made with landings, because of course the hardest bit, I suppose, is the weather. Everything is fine and dandy when it's CAV-OK. CAV-OK means good weather.
So weather being the number one variable.
It is the variable that catches a lot of people out. Technical issues, yes, I suppose that doesn't help, but the main thing that on a regular base makes the job more interesting, I would say, but harder in some respects, is the weather, because you've got an awful lot of decision making to do regards where you're going, when you're diverting, etc., how much fuel, how much weight, all of those other parameters that govern whether an aircraft can fly safely or not.
But there's obviously a decision to fly the plane or not fly the plane. How severe does the weather need to be for you to say, no, we're grounding this plane and we're going to wait it out?
It has to be very, very severe. I mean, in terms of never flying, I don't think I've ever never flown. But you need a viable alternate. So you need to be able to arrange your payload, your number of passengers, and your amount of fuel so that you can always get yourself to a safe alternate in case the weather doesn't improve at your destination.
But planes don't fly with an incredible amount of surplus fuel, correct?
Yeah, well, that's the problem with the low-cost airlines in that they restrict the amount of fuel that people can carry, and they take bare minimum. And the bare minimum should get you to an alternate, but of course, then when you get to your alternate, you're almost on fumes. It's nice to carry a little bit of extra, which most people strive to do in normal airlines, but they're not allowed to do if you're in low-cost airlines, which is why it's not as safe to fly in a low-cost airline.
Like the ones that you fly.
Yeah. No, actually, we're allowed in my particular airline. They're not terribly fussy if you take extra fuel. In fact, if the weather is actually bad, they will encourage you to take extra fuel, which is good. There are problems sometimes when an aircraft is working on its limits and you're full with passengers and you're working to a far destination when you're totally restricted on the amount you can take. And so you will be down on minimum fuels at that time because you cannot carry any more. But that minimum fuel should always allow you to go to your destination, then divert and land at an alternate airport. So that is covered within the regulations, but it's nice if some people carry a bit extra because there are always unforeseen circumstances. There was a famous case in Europe a few years back where a low-cost carrier went into a major European airport and they were all carrying minimum fuel. The major airport was closed, and so they all diverted at the same time. And now they're all on minimum fuel, and they all went to the same alternate airport.
So many runways.
Yeah. How many runways? Well, it only had one runway. The alternate airport only had one runway, so you can't fit all of the aircraft in at the same time. So it was just as well that there were other air carriers there who had carried a bit of extra fuel, who were able to hold and wait while the low-cost carrier landed all of their aircraft first because they had no fuel left.
And is it the air traffic controller that coordinates that between all the planes?
Well, only if you shout and scream that you have a fuel emergency. Air traffic doesn't know how much fuel you're carrying.
So they're not going to say, okay, you're going to come in first, you're coming in second, you in third because of such an issue.
Well, yes, they will if you declare a fuel emergency. So if you declare a PAN or if you declare a Mayday, then you will get priority. But when everybody is in the same situation and everyone now is having to give way to the low-cost carrier because the low-cost carrier doesn't have any fuel, then it does make you think, well, why do we have to give way to the low-costies all the time just because they're skimping on the fuel and not taking enough?
So let's say you're leaving JFK and you're landing into Seattle, which is like about a five and a half hour flight, right? How much extra time would you have on average?
The regulations are pretty much the same around the world, is you must have enough fuel to get to your alternate, whatever that is, and it's normally around half an hour or 40 minutes to get to your alternate, and you must have half an hour fuel on top of that. So that's your minimum fuel, is to carry alternate fuel plus half an hour. So if you did have to divert, so you go to Seattle, the weather's is no good at Seattle, so you have to divert to your alternate. You fly to your alternate, and you should be landing with half an hour's fuel left in the tanks. But half an hour's fuel is not very much. I mean, if for whatever reason you had to go around at your alternate to do another circuit, well, you're not going to be landing with very much fuel. So, yeah, nerves would be on edge a little bit, I suppose, in that sort of situation.
Interestingly, I went from Vancouver to JFK once. We actually did a touch and go at JFK, and the pilot pulled it right back up, and we went and we did a big circle around and went and then landed in again. And I could see that the flight attendant was a bit uncomfortable.
Yes. Well, it's not something that happens very often. So
the first time I'd ever have it happen.
Yeah, even with an experienced cabin chief, it might be the first time that that's happened. And of course, the trouble is with being a backseat passenger or a backseat driver is you don't know what's going on up the front. I mean, I have that problem all the time when I'm positioning.
I think communication's important. When the pilot talks to the passengers, it does help. There's some reassurance there.
does help, but it's very, very busy up front when something like that is happening, because you can imagine if you're having to do a go around, then the situation is out of the normal. And so there are extra stresses, there are extra problems. You're trying to deal with something that is now a non-normal situation. And so you're often quite busy. So I'm not surprised sometimes that pilots don't go back and explain to the passengers what's going on, simply because they're working quite hard up the front. And so if you do get someone that comes on the PA and just says, sorry, ladies and gentlemen, we will just be delayed 15 minutes and we'll be coming back in very shortly, then you can be sure that the guys are quite on top of it in front, because normally it's very, very busy when something like that happens.
Interesting conversation. We've covered quite a bit more than just almost an overview of how planes work and such. There seemed to be some disbelief, maybe, in the comments that whether or not you're a real pilot or just someone who likes to play around with flight simulators. So I thought we'd cover a little bit more. Some say, well, you're not an engineer or an aerodynamicist. How do you know what you're talking about?
Yeah, I know, but I know how an aircraft works, and I know how they should work, and I know what the product should give me. So I'm the end user, I'm the driver of the car. When you go into a garage and you buy a brand new car, you have certain expectations about what that car will do and how easy it will be to drive. Well, as a pilot, we have the same expectations. All aircraft are different. Some are better than others, but we have the expectation of what the aircraft should give us. And the primary thing we're looking for is, of course, an aircraft that's easy to fly and is safe. It has good backup systems in case something goes wrong. And of course, for the last 50, 60 years, we've always been quite certain that whatever happens to our aircraft as we're poling along, whatever fails, the backup systems will work and we will continue to our destination uneventfully. What we don't expect is to have a system failure that results in an aircraft that is almost unflyable. That is unforgivable. And that's why I'm so hacked off with Boeing not making a product that we would expect to have.
They should have done things correct the first time, but let's assume that they've done the work now and they're under so much scrutiny. Would you feel comfortable flying a 737 MAX upon the re-release?
It is still not the system that should be fitted to the aircraft. And I have to say it again, if you're going to have an anti-stall system, which is effectively what MCAS is, the anti-stall system should be working on the elevators and the control column. It should not be working on the trimmer. To make it work on the trimmer is a sticking plaster that is very cheap. And that's why they've done it, because it's a very cheap sticking plaster. And when I fly an aircraft, and if I buy an aircraft, I don't expect it to have sticking plasters on it. I expect people to have designed it properly in the first place. And you shouldn't have an anti-stall device working on the trimmer. It's the old adage of aviation. When you start aviation from square one on your first flight in a Cessna 152, and the instructor will say, don't fly the aircraft on the trimmer. That's not what the trimmer is for. You fly the aircraft with the control column and you use the trimmer to take out the control forces. That is aviation 101. That's how things should work. You don't make the aircraft fly on the trimmer. And we've got an aircraft with a sticking plaster on it. So no, I don't think that's, it'll work, it'll sell, it'll fly, it'll probably be safe-ish, but is that the right way round to do this? No, it's not. And it's rather galling that we have a manufacturer in the 21st century that is effectively pushing out substandard products, really. It's not how it should be designed. So am I happy with the 737? No, I'm not happy with it. Will it fly? Yes, it will. It'll probably be safe, but it's not the way aviation should be working. But this happens, this is not just Boeing. This happens time and time again where manufacturers get away with substandard products and are not held to account. We looked at the Ford incident before with the Ford Pinto. We've had this in Britain a lot recently with white goods. White goods we call kitchen equipment, white goods. Your fridge, your washing machine, your freezer, all that sort of stuff. We've had numerous product recalls and failures because of substandard goods being sold. It's becoming, I have to say, more prevalent than it used to be. I don't remember quite so many failures of products as we have now. I don't think it's just because we know more about it than before. I think people are getting a little bit sloppy because they're concentrating too much on the costs rather than the safety. What they should do is sell a few 737 Maxes, but have a project now. Well, not now, started last year to create the new 737 replacement for the Max. But they need to start doing that now in order to get it out and on sale in 10 years' time and do the job properly. Make a 787 Mini is what they should do. The technology is there. The design capability is there if they bothered to use it. But unfortunately, it's a management problem. It's not strictly a designer's problem. They can only do what their design brief says. But if you let the designers free to go and design something, they'll probably design something that is world class, if they're allowed to do so.
Regardless of how well they refurbish the 737 MAX, its name is forever sullied.
It's tarnished, isn't it? What are they going to do? Are they going to rename it or something? What do you reckon?
Well, they have to make some change enough that it warrants a renaming, basically.
Yeah. Well, they can't call it the Max, that's for sure.
No. But, when you book a flight, you don't know what plane you're going to be flying on. It's not as though you really have a choice in the matter. You've booked flight 1237 out of such and such. It's only at that time that you learn what plane you're on. So it's not as though the consumer really has a say in the matter of which plane they're flying on. Audience question, last question of the day, and it's the ultimate question, really. Does Boeing leadership have what it takes, the strength, the integrity, the resources, the time, to regain the trust of the airlines, the pilot and crew, and the passengers? It's the ultimate question.
It is, and it's a good question. At the present moment in time, one would have to say no, they don't. They really have to have a management shake-up in order to get the house back in order again. Just getting rid of that CEO is not a management shake-up. The culture is still there. The culture of sell, sell, sell. And we don't care what we're selling. We're just selling a product. What are you selling? Product. Yeah, but what's it called? Well, it doesn't have a name. It's just product. We don't care what it is, what it does, what it satisfies. It's just product, and we sell it, and we make money from that. That sort of management attitude has to be reworked fundamentally for a company to get itself back on its feet again. And just dismissing one CEO is not going to do that. To satisfy the customer, and ultimately the customer is the fare-paying passenger, because you can look it up online which airlines are flying one aircraft and which airlines are flying a different aircraft. So you can tell which airlines are flying that particular aircraft.
But nobody does.
No, because people go on price. Yeah, I know what you mean. But fundamentally, to get the trust back again, they need a much bigger management shake-up than has happened at present. Really, the customer needs to they need to see that something has been done, that people have been held to account, that people have been dismissed, that people have been fined, perhaps. I mean, what does it show to the fare-paying public when 2 aircraft have crashed for no good reason? The fault, as Congress is basically saying, that influence from Boeing resulted in FAA management rejecting the safety concerns raised by the FAA's own technical experts. Now, that comes from the very top of Boeing. And so what do? They dismiss the CEO and they give him, what did he get? $64 million severance payment? Anyway, it was in the high millions he got as a severance payment. What is that showing to the rest of the managers at Boeing who remain at Boeing? It's telling them that they can get away with anything and they will be paid to go off into the sunset without any responsibility whatsoever for what's happened. It's like the 2008 crash. There was a great film, I think it was called The Big Short.
Yeah, I knew that's what you were going to mention.
Yeah, about the and it was very good because it was semi-documentary as well as being a film. It was like a documentary. And it went through all the calamities of what happened in the banking system. And then at the end, it said, and because of this great banking crisis, 2,000 top CEOs from all of the banks across the West were all sent to jail. And then there was a bit of a pregnant pause. And he said, sorry, just joking. Because nobody took responsibility. And so those same people are still there at the same banks, still making the same bad decisions with the same ethos that they had before, that they can get away with anything without censure. And Boeing is the same. Boeing has had a 2008 banking crisis. It's called the 737 MAX, and nobody has been held responsible. So how can anyone trust Boeing if nobody is being held responsible for the mistakes that were made? It's not possible. You cannot trust them. They have to sort out management. We have to see people fined, dismissed, and jailed. Otherwise, you cannot trust Boeing.
Paul, these past two shows we've done have been a pleasure. I've appreciated your involvement. It's really been illuminating having a real pilot to speak with.
I am a real pilot.
He is a real pilot.
I am.
I think we've proven that today. And, barring any unforeseen circumstances, will probably be the end of our talks regarding the Boeing 737. I don't know if it was fair to call it death plane, but we had to get people's attention so they would listen. Paul Spencer, thank you so much for being a guest on the Russell Scott Show.
My pleasure.